All right, last time we started chapter 5, so let's return to that. And apparently, well, not apparently, I didn't try to use the microphone on my computer here to record the last session, and it is bad. I don't know what it has to do with maybe the echo in the room, on the table or something, but so I guess the last recording didn't turn out very good. So I'm going to sort of go over some of the same stuff I went yesterday, last time, presented just a little differently. It's the same stuff anyway, and today's kind of a repeat of last time anyway. And there's a different quiz, but the quiz this time is the same as last time, and so on. So it's you know, it's not a bad thing for me to kind of re-emphasize some of this stuff, just because this is starting to get a little bit more complicated, and we're starting to learn some things here now where if you were familiar with SQL before you came in here, you may have felt pretty comfortable. You felt comfortable detaching yourself from the record focus or record centric updates of SQL versus the entire relation, the table centric way of looking at updating database tables using relational algebra. But now we're getting into matching and not matching and image relations and some of these other more fancy things that you could only really think about if you are thinking, if your paradigm for looking at this is we're looking at relations with tuples and so on, rather than just records inside of a table. Why don't we first this time look at the quiz, because we've already covered this stuff somewhat already. So let me go here. Well, quiz is here, quiz 9, right? Today's the 19th. Better get another quiz up there. And this didn't have the same wording problem as last time. Okay, so in this quiz, we are looking at, we're looking at these same operations again, and we have these 3 database tables with these 3 tables. In this scenario, it's students enrolling in courses. So there's courses over here, and there's students over here, and they're enrolled in courses based on this table right here, where you have a student ID and a course ID, and a student can only enroll in one. It can only enroll in a course once. Obviously, a student cannot enroll in the same course twice. And CRN, yeah. And so pretty obvious. It's pretty obvious that the primary key for this table is both these together. The primary key for this table is this thing. The primary key for this table is this thing. And write the expression for matching. Write the expression using matching for a relation containing just the names of students not enrolled in a class. Okay, so if you recall from Monday, in this case, if we were looking at the set of students, if we were looking at the tuples in the students table, in other words, if we're looking at student records, and we want student records for students that are taking a course, that are enrolled in a course, we would do S matching E. S matching E would give us a table that looks just like S, except for it only has students that are enrolled in a class. And so students that are enrolled in a class is S matching E. So Scott is enrolled in a class. Tom is enrolled in a class. Isaac is. Adela is, but Sylvia's not. So it would be, so matching is just this. Well, we want students that are not enrolled in a class. So it's the students table minus this, minus S matching E. Or that's the same as S not matching E. So S not matching E is this, And so, but however, we do not want the entire S for a tuple. We just want the name. See, so there's a projection. So anyway, you're supposed to write the expression for that. Okay, so it's just an S not matching E expression, but then you put the thing for a projection. You only want the name and not the entire tuples, or not all the fields, not all the attributes of the tuples. All right, that's the first one. Second one. So this is like an update, or this is like it's like a extend. This is an extend, except for we're out coupling it with an update. Okay, so we're going to extend. We're going to update C, and this variable here is number of students enrolled. So this number here is the number of students that are enrolled in Business 310. And so that would be just one. And the next one is Business 311. The number of students enrolled in Business 311 is, that's 414, 2. Number of students in Business BUSA 345 is 1, 2, 3. Number of students in ICS101 is 1. And the number in ICS321 is 1, 2, 3. So those would be the numbers that go in here, yeah, number of enrolled. And so we're using a matching. We need a matching in there because we want to figure out what the matching is for this record, the E, the bang bang E of this record, which would be this, and just that, and the bang bang E of this record, the bang bang E is it. Okay, it doesn't include the CRN because the CRN is, we know what that is. It's all of the ones where CRN is equal to that. And so that would be that would be this one, and this one, and this one, I guess. So yeah, so that's the bang bang. So you do bang bang, you do the bang bang E for this course, and you get an image relation, and the number of tuples in the image relation is the number we want, because it's the number of courses that it's the number of students. It's all the students enrolled in that course, and all we want to know is the number of them, the count. So this here is the count of the image relation of the record, the tuple in C. It's a C. We're talking about C. We're trying to update this thing. So we take the image relation, E image relation, count them up, and stick that number right there. So you just have to write the expression. Go back and look at old stuff. Okay, so that's what goes there. Okay, now here I actually have you just so you really know what's going on, and we're doing a truth table here, and we're evaluating an expression. We're going one tuple at a time. Okay, so we want to evaluate this expression. We want to figure out what the result is. What is the result of this? Well, geez, I don't even know what it is. It's just there's a bunch of, you know, symbols there, and well, let's see. Let's look at this now. It looks like this is one whole parentheses. I mean, this is the outer parentheses here. It includes all what's inside here. All this. It's that. You evaluate that, and that must be a relation because we want a projection of that relation. Okay, so that means the result is going to be a bunch of names. It's going to be a column of names. Okay, that's what we have here. So it's this column of names here. But and so the answer to SID21. Okay, so it's the answer. You know, going through the steps, evaluating for this one, for Scott. If you evaluate all these things, you end up with this is this, this is this, is this, and the projection is just a name. Now, some of the other ones, there might be more names. What this is, prove the following expression produces the names of the students taking exactly the same courses as Tom Brower. So we want to know the names of the students that are taking exactly the same courses as Tom Brower. And we go down the line. Okay, so, geez, I hope this is right. I'm pretty sure it's right because I worked it all out. But I have to make sure I'm asking the right question. It's been a problem with my quizzes lately. I haven't been asking quite the right question. And the poor grader, the grader gets it and says, okay, I have Halverson's key here, and then I got the first 10 quizzes I graded, they all say the same thing, and it's not what Halverson's key says. You know, what do I do? And you know, I just let the grader run with it, and he probably says, well, Halverson's key is wrong. I got a grader for it, so whatever. But anyway, let's make sure we get these questions right before we have to turn the quiz. Okay, so let's do the first one. Okay, so we want to know. Okay, so it's all the students that are taking exactly the same courses as Tom Brower. So what courses is Tom Brower taking? 22. So he's taken 62, 3, and 366. He's taken. That's all he's taken. 62 and 366. Okay, so he's taking this one and this one. So Tom's taken 62 and 366. Okay. Now what's Scott taking? Scott is taking. Oh, I know. Yeah, right. This is the answer. This is what we're looking for. Not this. What's Scott taking? Scott's taking 303, 414, 366. So he's taken this one, and this. That's not the same as Tom. Okay, that's why it's a false here. But anyway, so that's what this is where the final answer is. And so if one of these is true, then that row, that guy, is taking the same course load as Tom Brower. We should see that 22 is the same course load as Tom Brower, but we don't because we exclude them out here by saying we're excluding the ones because SID is 22. See, SID is 22. All right, so let's see how we derive this from this and this. Okay, so first of all, it's S where this is true and this is true. Yeah. Yeah. So, right. So this here is the image relation, of E for, S. The image relation of E for S. And so for 21, the image relation for E is this, 303, 414, 366. That is this. This is this. And so this is what the image relation is for SID equals 21. It's the courses that SID 21 is taking. It's the courses that this guy's taken. It's this one, and this one. That's this one, and this one. Okay? So that's what that is. And we have to test to see if it's equal to this. Well, what is this? What is this anyway? Well, it's first of all, it's these are the courses Tom Brower is taking. Because this is the bang bang E. This is the courses that where SID equals 22 is taking. So this is SID equals 22. And what is the bang bang E of SID equals 22? Well, that's the courses 22 is taking. Okay, so that's this. And in fact, this is going to be the same for all of them, right? Because this is the same for every one of these. Do you see that? You see that? Okay, good. After this, I go back to KCC and I'm teaching this ITS128 class, and it's like 111, except for it's more fundamental. Over there we have 3 courses that cover what 111 and 211 covers here. Okay, so I'm teaching them the concepts of so C# is exactly like Java. So I'm trying to teach them about event handlers and programming and methods and boy, some of those concepts are really hard for some people. Especially folks that are coming back. They spent their career on a Navy submarine and now they're coming back and they want to learn how to program. And it is kind of I hate to say this, kind of arrogant, but it's kind of a pleasure to come over here because you guys are much higher level and I can throw stuff out there. And even if you don't catch it right away, you know how to talk amongst yourselves to get the concepts. You got that room up there on the 3rd floor. So it's pretty cool over here. So anyway, when I say that everything in this column should be the same, then you nod. I believe that you understand it. We have an expression here, and it's S where SID equals 22. That's always going to be this, and we want to know what the courses are that Tom is taking. This is the image relation. So this is going to be the same for all these rows. So what we're doing is we're comparing this, actually this, this on the S for all these. So one thing we can do is we can just go down the line, okay? Now for 22, when we evaluate all this, this makes it false because this right here is going to be false. This is false, and so it doesn't matter what is over here. Here, let's step back and look at this one here. Right, this is just a name. When we evaluate this is the image. This is the courses that this guy's taken. No, this is the course that Tom is taking, and this is the courses that this guy's taken. So we compare this one with this one. So is this equal to this? No, it's not, so that's false. Okay? So that means that this whole thing here is false. This here is the evaluation of this expression. And this, and so that's this. No, I'm sorry. Yeah, that's that. And then, yeah, right. This is the evaluation of this expression. Because this is this, and this is this. So the question is equal. Is it equal? So is it equal? So is this equal to this? No, it's not. Okay, so this whole side is false. So that means this whole thing is false. That means the where evaluates the false, which is why it's here. Okay. This is true because in this case SID is not equal to 22. SID is equal to 21. Okay, so that's the evaluation of this whole thing. And then if you look at SID equals 22, well, you know, this is an and here. SID is not equal to 22. Well, this is false right here. So it doesn't matter what this here evaluates to. It doesn't matter what this evaluates to. This is going to be false. Okay, so this one is false. For 23, you know, for every one but not 22, this is true, and this is true. Okay, it's only this one that's false. So if all these are true, then we have to evaluate what these three. We have to figure out what these three things are. Well, we already know what this is over here, so we have to figure out what this is and check to see if this is equal to this. If this is equal to this, then we found a match. Otherwise, we haven't. Okay, so let's look at 23 and look at the image relation for 23. Okay, it's Isaac. What courses are Isaac? What courses are Isaac taking? 62, 205, and 414. That's not the same as Tom, so Isaac fails. How about 24? Who's 24? 24 is Della. 24. Della is taking 62 and 366. What's Tom taking? 62 and 366. Whoa, we have a match. This is exactly the same as this, which means this is a true. And because this is also true, this is going to be true. So the names that come out of this one, which is going to be it's like, I don't think this is, it's this. Yeah, okay, yeah, this produces a relation. This produces a set of S's, just one. And then this is the names from that. No, the name from that, the name from this. Okay, so anyway, that's Della. And then 25 is Sylvia. Sylvia is not taking any classes, so this is empty. So empty is not equal to this one. So this is false, so that one doesn't pass. So anyway, so for this quiz, you just have to fill all that in. Hopefully the microphone is working this time. All right, so what may have been foggy for you is the image relations part. So I'm just going to go over that again. I'll buzz through these. Slides. Did I get all the way to the end last time? 34. Oh, what's going on? Okay, here we go. Yeah, I think I probably did. All right, so this chapter goes over matching, not matching, extending. Extending means you just create a new column, and it's some expression of other attributes in the same tuple. And then image relations, which I just talked to you about. An image relation goes inside of a. It's like it's inside of it's like an attribute, but it's not a scalar value. It's not a primitive value. It's an actual relation. And then at the end, this chapter talks about aggregation, summation, and where you sum up a bunch of rows. You do a sum function on a tuple or on an attribute of a relation, and it sums up all of it. You know, it sums up those attributes, for example, or it counts them. So that's like an aggregate function, and so we go over those. Okay, so matching. Another name for matching is semi-join, because we're actually doing a natural join. So it's got to be a common column, natural join. But we only care about the attributes in S. We only care about the tuples in S. We only care about the tuples in S where the semi-join took, or where it matched in SP. So for example, S matching SP. SP, you recall, are the shipments. The shipments, there's a supplier that ships parts, and so you have a supplier. A supplier may or may not have parts being shipped. A supplier may have lots of parts being shipped, or the supplier may only have one part being shipped, or the supplier may have no parts being shipped. What S matching P is give me all the S's that have a matching SP, and an S tuple is only going to be in there once, because what you end up with is a relation. So this is the answer to that. You recall that maybe you don't recall. Let me recall it for you. So we have S and SP, and there's an S for every S. There's one in S. There's at least one in SP, except for S5. There's no S5s in SP, but there's S4s, S3s, S2s, and S1s. So that's why only 1 through 4 have a match. 5 does not have a match. So that's why we just see the tuples. We see the full tuples of S, but we only see those that match. And so you can call it semi-join. That's another term for it. It's actually just this, where we take S and we natural join it with SP. In here, join. In this, the join is, in his language, join is like natural join, but in SQL, it's like, well, actually, it's like a product, cross product. It's a cross product where you only keep the tuples where the SPs are equal. I mean, the S's are equal. The SNOs are equal, basically. But anyway, so S matching P is just the natural join of S and SP, along with a projection of just the attributes in S. So we leave off any attributes in SP that are not in S, and those would be, you know, so we would only include SNO, because SNO is in S, obviously, but PNO and quantity are not in S, so that's why they are included. And not matching is just S minus S matching. S not matching. It's everything else that's not S matching SP. does it give the example here? Yeah, this is a easier way to look at because we remember minus, what minus is. So we take S matching SP and we take that tuple, we subtract it from, we minus it of the full S, and we get what's left over. S not matching SP. All right, and then we have this extend function here where we can add what looks like an attribute or what looks like a column, but it's actually a computation, an expression involving other attributes in the same tuple. And so here we're taking the weight in pounds and we're converting it into grams, and so that's what it ends up being. Here we are extending. Well, here first of all, we are only grabbing. Okay, first of all, we're doing this. We're creating this new attribute, GMWT, and then we are doing a restriction where we're using GMWT as part of the restriction expression, which is okay in his language, but in SQL you can't do that because it's too late. I mean, when it's executing the where clause, it doesn't know enough about GMWT to be able to use it in an expression. So if you do this, you actually have to take this and put it here for that to work. Okay, but anyway. And then from that, we're just taking a projection where all we are putting out is the part number and its weight in grams, its mass in grams on Earth. Here's an example where it's not even any kind of expression. It's just a constant that we're adding an attribute, and it's going to be the same for every tuple. You might do something like this if you have a bunch of suppliers, but they're from I don't know. You have a bunch of tuples around that look just like SNOS name, status, city for some. There's suppliers and there's consumers, or I don't know. It's just a bunch of things that where to represent them in a relation, you use the same set of attributes, the same kind of header. But let's say you want to combine all these different things into one great big relation. The only thing is now you have to actually start distinguishing what the differences are between the different groups by an actual attribute. And so you would do this for all your suppliers and all your processors and all your subcontractor or whatever, and then you'd add that tag field, and then you would union all them up, be a big union, and then you'd have this big, larger relation that's got all the information in there, but what the group it came from is actually in a new attribute, this new extended header here. Anyway, I've done that before. Here we are. First, we're here what we're doing is we're actually extending, and the relation or the expression comes from the two different tables. We want to figure out what the shipping weight is. And so we have to take the parts, the weight of the parts, the weight of a part multiplied by the quantity, and we get the shipping weight for that particular shipment. And the weight is in the parts table, and the quantity is in the SP table. So you take one attribute from each, make this new ship weight, and you need to it depends on the join. You have to do the join first, but then you get this third, this new attribute value. Rename is simply a way of at the table level or at the relation level, before it's exposed or before it's used, you rename one of the attributes. Why would you do that? So the header matches some other header of something you want to intersect or join or do something where you want the city, where you want the attribute names to be the same. Or you may want to change them because they are the same. In this example, we are changing them because they are the same. So why would you do that? Well, let's say you want to do you want to do suppliers, natural join, supplier parts, SP, natural join P. And what you would want is each supplier, for each shipment, it's got the supplier information and it's got the parts information. So you'd have a record, you'd have an attribute. Okay, I'm talking about S, natural join SP, natural join P. That's not quite this. Well, you can't do that because you've got the city field in the parts relation, and you got the city field and the suppliers relation, and they mean two different things. I mean, they're both cities, but one is where the headquarters of the supplier is, and the other one is where the warehouse of the parts is, I guess. And so, but we'd like to do a natural join. So what we can do is we can rename one of the cities something not city, and then it's fine, because then the SNO in supplier will natural join nicely with the SNO in the SP table, and the PNO in the SP table will join naturally with the PNO in the parts table. And the cities don't do anything because one of them has been renamed, and so they don't have the same name anymore. So the database engine won't confuse the two and actually try to do a join with those two. I mean, you can see what that looks like, and we probably will later. All right, so here's an example of we actually just changed the meaning of an attribute. Let's say we don't want weight to be pounds. We want weight to be really mass, I guess. And we still want to call it weight because it matches everything else that we're doing. So you can just do this. You can just say weight. The weight is now weight times 454. Okay. Here's image relations again. You can read about them here. We talk about them. Matching, not matching, extending. Same examples. Extending. So here's image relations. You can read more about them here. And so they are an image in some relation of some tuple. An image relation is an image in some relation of some tuple, usually a tuple in some other relation. That doesn't really make too much sense to me. In some relation of some tuple, in some tuple of some relation sounds to me like it'd be a better way to put that. Put an of here and an in here, but anyway, so for any particular tuple, take a tuple. It's got an S. Let's take a tuple in S. Let's take SNO equals 1. That's a tuple in S, and we want to know what the image relation of SP is with respect to that particular tuple in S. So that tuple in S is, okay, so let's do this one here. SNO equals 4. So we from S4's perspective, let's look into SP. From S4's perspective, all S4 can see is other S4 tuples. Okay, so we have SP there, or we have SNO there, we have S4, and it takes a look, it peers into SP, and the thing is S4 can only see S4 records. So all S4 sees is these records. Okay, and really, we don't need the S4 because that's redundant because it's S4. So really, the definition of the image relation is just these without the S4. Okay, so the image relation of SP for S4 is this. Okay, let's try S2. If you're S2 and you're looking over into SP, you're just seeing stuff from S2's perspective. All you're seeing is these here, okay? And in fact, you're blind to yourself, so you don't even see your S2s there. All you see is these. Oops. All you see is the. Let's call it this. So that is the image relation of SP with respect to S2. And the image relation of SP with respect to S5 is that S5 looks over there and says, hey, I don't have anything over there, so it's empty. Oop. And here is a small example of like the exam yesterday, or the Monday quiz. We want all the S records where this is true. Well, we evaluate that for every single S record. Okay, so for every single S record, this is going to be different because every single S record, when it peers into SP, it's going to see something different. When S1 peers in, it sees with respect to S1. When S2 is different, it sees with respect to S2. So this is going to be different for every SNO. This, however, will not be different for every SNO because this is just the P&O projection of P. I mean, all this is the column of P&Os, right? We know that. It's take the P relation and just project to me back the P&Os, and you're going to see 6 of them. P&O 1, 2, 3, 4, 5, 6. So that's what this is, and it's going to be that when we evaluate each of the tuples in SNO and S, that side of the equation is going to be the same. This is the side that's going to be different. Well, we want to find those tuples in S where the projection of P&O is equal to this thing, and what that is it's suppliers who supply all the parts. This is the set of is the set of parts. This is the set of parts that particular supplier supplies, or is supplying, or is shipping. So with SNO equals 1, okay, when we do this, for SNO equals 1, what is it? SNO equals S1, it's just going to be, this. Okay, that's this. This for S equals 1, SNO equals S1 is this. Now, we only want the P&Os. Okay, we only want P&Os, so that is just this. Okay, so that is the projection of, that's the P&O projection of the image relation of SP for S1. Well, that's exactly what this is. That's exactly the same. So for SNO equals 1, S1, this is the same as this. It's not the same for any of the other ones. For any of the other ones, there's no other ones here. There's no other SNO where they're shipping all of them. It's only S1. So that's why it's only S1 where this is true, and that's why the result is just the one tuple, the S1 tuple. So that's what an image relation is. This is just we sort of put these all together, and he introduces this concept of a temporary variables. He calls it a syntactic trick. Okay, so it's getting to be more and more like a programming language where you have a sequence of statements instead of one huge expression. And of course, this is a perfectly fine thing to introduce to you folks because you're programmers and you're looking at relational algebra from a programmer's point of view, and you're probably thinking, why not do it this way? That's good thinking. But if you are a math person and you're used to writing just expressions, and if the expression's going to do more, you just put more in parentheses and closure and all that. And your expressions can get big and deep, and it's not obvious to you right off. Well, let's break this down a little bit and define some variables here that are only going to be used temporarily, and then when we're done using them, we won't need them anymore. That's a programming thing. But anyway, that works well in his language. When we start using sets and so on, it starts to get complicated. So I don't need you to spend a lot of time on that. What is J? Oh, projects. Projects. All right, aggregate operators, two important ones are sum and count. And in SQL, you turn a regular SQL statement into something that will aggregate by using a group clause after the where clause. And I'll show you that when the time comes. So here we're this sums up the quantity values. No. First of all, we take SP and we project the quantity. We project just the quantity attribute, and remember it's a relation. So I know you know there's a lot of 100s and a lot of 200s and a lot of 300s, a lot of 400s in that SP table. But when we're all done taking this, it's only going to be a 1 100, 1 200, 1 300, and 1 400. See, all we have is 100s, 200s, 300s, and 400s. And so when we just look at this column, and then we turn that and we look at that as a relation, there's no duplicates. So this is simply adding up 100 plus 200 plus 300 plus 400, and that equals 1,000. So that's why it's 1,000. On the other hand, this thing sums up all of the quantity fields in SP. So this is a different notation than this. This takes a this is summing up everything inside here. This is inside this column, and this is summing up this field and this. So that's why this is 3100, because 100 gets counted as many times as it is. This really is the sum of all this, which is 3100. And there's also average and max and min. I guess we use max and min sometimes. We don't, we don't use average too often, but if you're in an application where you're computing the averages of something, yeah, then you're going to use that. And of course, you can do sums and maximum on image relations just like you can on images. See here you want S where the number of suppliers is less than 3. That's a clever way of doing it, right? This is how many suppliers the guy has, because it's looking in this whatever, or how many parts, no, shipments. Yeah, shipments. Same thing. So these are just fancier ways of doing the same thing. All right. So that's a good review of the chapter again, and I went over the quiz. Are there any questions? All right. I guess we can start chapter 6, whatever the next chapter is next time. Thanks. Yep. Thanks for watching.